Hi, and welcome again to the CDFM study group. My name is Helen Thomas, and we're continuing the review of CDFM Module 2.2, Cost and Economic Analysis. We're going to continue page 2.2.63, and we're talking about inferential statistics, where it deals with coefficient of determination and coefficient of variation. So at first, we talked about the measures of correlation and how well data correlate or not correlate. And coefficient of determination is simply the square root. So you have to read through these to get the formulas because you may be required to do these calculations. So I'm not going to read through these because they're right there. All right, when it comes to doing cost analysis, economic analysis, cost analysis fundamentals, we look at constant dollars, because this is when you're trying to estimate how much it's going to cost for you to make a purchase in today or in 5 years, or you're investing in something today for a 5-year period. You want to look at how much it's going to cost me for this 5-year project. So you can either estimate using constant dollars, where you remove the effects of inflation, or current dollars. And you can usually go to the ODASA CE, Office of the Assistant Secretary of the Army, for cost and economic analysis, and or the current dollars, the buying power of work done. So your current dollars are expressed in the value of the year in which the cost is expended. So you understand that the dollar today will not be worth the same thing tomorrow. So there are inflation factors, there are depreciation factors that have to be included in the economic analysis to then determine what will it cost to me to invest in a 5-year product that has reoccurring services each year. How much is that dollar going to be worth in the second, the third, fourth, fifth year of that request? So in the bottom of page 2.2.64, you see the constant dollars, current dollars, or another cost is sunk costs. Sunk costs are expenditures from prior fiscal year. The bottom line is an investment that is a one-time cost, that is typically a cost that you have to make, and you cannot recuperate the dollars. So sunk costs. On page 2.65, discounting and present value. So now you're actually going to do an economic analysis, and you will be required to perform an economic analysis on a scenario that will be given. And they have enough examples in the next couple pages and at the end of the lessons where you have the exercises. I will advise you to do the exercises, and if you can't figure out the values, you can send me an email and I will email you the answers to the exercises, because this one you definitely will have to do. So the present value formula is listed on the top of page 65. Present value factor equal 1 divided by 1 plus the discount rate, and all of that is squared to that time of the project. So if it's a 2-year project, 3-year project, you then raise it to that value. So if you do that calculation, you can see at the bottom of page 2.2.65, that's how they do the calculation to give you the discount rate that you need to subtract from that dollar amount or multiply that dollar amount, because again, the value of the dollar today will not be worth the same thing tomorrow. So you have examples starting on the bottom of 65 and 66. They have an actual chart at the top of 66 where they actually have a problem. And assume a 5-year project that would commit the organization in a stream of dollar expenditures. So you make an initial payment, year 0, and then year 1 through 5 is your recurring cost. And it shows you how to do the calculation. It tells you the present value cost for each year is calculated by multiplying column 2. On the test, you will not receive a chart. So it will behoove you to draw your own chart Set it up like this, learn how to do this problem, and then when you get to the exam, you also want to draw, because you'll get a pencil and a blank sheet of paper, that scratch paper, that you can draw your own chart if necessary. Page 66 is your break-even point. So at what point, what year will I recuperate all the money that I've made in my investment? So the bottom of page 67 has an example. If I make $1 million investment with an annual operating cost of $50,000, the proposed system will replace a current capability that has an annual operating cost of $300,000, therefore saving $250,000 per year in operating costs. How many years will it take for the savings in operating costs to equal the investment cost of the proposed new system? And it shows investment is $1 million, savings is that $300,000 minus the $50,000, which is $250,000. So 1 million divided by 250,000 is, it'll take 4 years for us to break even. Now for page 2.2.69, which is exercise 2.2.1, I will advise that you do this exercise because it will train you to break down the life cycle costs, which we talked about earlier on in this lesson. We talked about the development costs, flyaway costs, weapon system costs, procurement costs, program acquisition costs, and we actually talked about calculating the program acquisition unit cost, operations and support costs, and the life cycle, the total life cycle cost. So you'll be given the values such as what's in the middle of page 69, then you have to calculate. So for this one, I think I can walk through this without any major calculations. So development cost is, remember, if you go back to the life cycle chart, your development is the first stage. I'm developing the system, so I need to do research. So that's my RDT&E dollars. That's 400 million. The next is my flyaway cost. Flyaway cost looks at the purchase of the prime procurement item. So that is 600 million. The weapon system cost is the cost of procuring the prime item plus my support procurement. That cost is 650 million. Procurement cost is simply adding up everything. All right, the next one is program acquisition cost. And remember, program acquisition cost was your RDT&E plus your military construction plus all of your procurement costs, and that should add up to 1,200 million. Everything minus O&M and your MilPers. Let's see. So operations and support is your O&M and your MilPer, and that also adds up to 1,200 million. Life cycle cost is the total of everything. So that should be 2,400 million. So you should be able to do those calculations and then go back again to the picture of the life cycle cost to see what it takes to calculate development, flyaway, weapon system costs, and so forth. All right, on page 70, it goes into the average unit cost of an acquisition system. They give you the data. After being used for developmental test and evaluation purposes, 3 units of the weapon system acquired with RDT&E funds have been successfully modified and are planned to be deployed to operational commands. These 3 systems are considered fully configured end items produced for the acquisition program. So the first one says and the second bullet says there are 297 fully configured end items procured with procurement dollars. So the first one was procured with RDT&E dollars. The second one was procured, the 297. So I got 3 up there, and I got the 297 was procured with procurement funds. So compute the program acquisition unit costs. So what do we need to do that? All right, so this problem is then also you get the values from the previous page. So we said that program acquisition cost, if you go back to page 69, program acquisition cost is $1,200. So let's go back to page 70. So compute. So 1,200 divided by the number of configured items. So we have the first one was RDT&E, because remember your program acquisition cost is RDT&E, procurement, and Milcon. We don't have any Milcon, but we have RDT&E, which was 3, and 297 of the procurement. So the total of 300. So 1,200 divided by 300 should give you 4.000 million. That's how you do that problem. So he says choose the correct answer. All right, the second one says compute for average procurement unit cost. So procurement cost is all your procurement total. So let's see what that was. Procurement cost was 700 million. So you do the same thing. Compute for the average is 700 divided by 297, because if you go back to the top, the second bullet addresses procurement funds. The first one was RDT&E funds, so we can't use that for average procurement. So the second one, it says 297. So 700 divided by 297 equals 2.357. So that's how you do that. All right, let's go to unit cost in labor hours on page 71. So you have unit cost number 1, labor hours 190, number 2, 171, number 4, and so forth. So then how do you get the additional values? Well, let's go to the instruction. Given the below information, determine the unit cost of the 8th and the 16th item to be manufactured. Assume a 90% learning curve. Use of the multiplication is required to complete. All right, so we have a learning curve of 90%. So if you take 90% of 153.9, that will give you the value for the 8th item. And then if you take 90% of the 8th item, and you will get the 16th. So for instance, on page 71, the unit number 4, labor hour, is 153.9 hours. If you multiply 153.9 hours times 90% or 0.90, you should get 138.5. Then if you multiply the 138.5, which is the 8th hour, the unit number 8 times 90%, 0.90, the unit number 16 labor hours, it'll take less hours of 124.65, or you can round it off to 124.7. So the bottom line, learning curve, to see how long it'll take as the number of units are produced increase, double, it'll take you less time because you're experienced. So it'll take you less time, less labor hours, man hours to do the job as you produce more items. All right, so I'm going to also do the exercise 224 on page 72, learning curve percentage. Now this one is saying for you to calculate, is asking you what is that learning curve percentage. So now you have the unit numbers, you have labor hours, and you need to calculate the percentage. And the percentage is going to be the same for all. So the bottom line is you're going to have to do some division. You're going to have to divide, let's say unit number 2, 595, divided by 700, you'll get 0.85 or 85%. And to check your answer, you can do another one. And you can back check your answer, because if you take, so if I say 85%, so if I take 700 times 0.85, that should get me 595. So I can check my answer. So even if you can't really divide, because again, you can't use a calculator, and if you forget how to divide, you could go down, okay, let me take 5%, 10%. All right, let's go 50%. And you take 50% of 700, you should give you the number, the next labor hour. If you take, and if you keep doing that, eventually you'll get to 85%. And if you take 85% of 595, you will get 505.8. So that's a different way, because long division, a lot of us, we use calculators and cell phones, so we don't remember how to do that. There's always another back way in which you can get the answer. If you have particular questions on doing this, please, or any of this really, go ahead and email me, and my email should be listed on the website. Okay, and finally, page 2273, the earned value management, kind of what we did earlier. So let's see if we can work this out together. Project A through I, planned work costs, compare budgeted cost of work scheduled to budgeted cost of work performed, the value of the work, cost, actual cost of work performed to budgeted cost of work performed, and actual cost. All right, so again, I'm putting my hand on everything to the right of value of work, so I don't look at that number. And let's say planned work, so the cost of what I planned was $487, and so you see they gave you the variances, but let's say they didn't. And compare that to the value of work done. 487, the value of the work is 487, so we're on target. We didn't really get anything there. All right, so the planned work cost, so it cost me $250 in my plan, but the value of the work they did was only $216. So that's unfavorable. The next one, planned work cost $719. The value of the work done, $847, and so forth. So let's go to the next one where you actually have to write the value. So if the planned work is $192, the value of the work is $192, you're correct, we are on target. Planned work was $352, and the value is $439. Well, yeah, thank them for making my house worth more, because the value is $439, so I have a favorable variance. Planned work $883, the value is $684, that is unfavorable. Planned work $449, value $561, that is favorable. Planned work $874, value $726, that is unfavorable. And the last one and that is the schedule variance. The last one on the schedule variance is planned $839, value $798. So that is unfavorable. I want to have more value out of the work being done for the cost that I pay. So the next part of the chart is put your hand over everything to the left of value of work done. So we're going to do the cost variance. So value of the work was $487, actual cost $487. Value of the work done is $216, but guess what? It only cost us $122, so that's favorable. Value of work done is $847, but we had to pay $875 to get that value. That is unfavorable. Value of work done, $192. Actual cost, $286. Definitely unfavorable. Value of work, $439. Actual cost, $564. Unfavorable. Value of work, $684. Actual cost, $521. Definitely favorable. Good deal. We like a good deal. Value, $561. Actual cost, $493. That is favorable. Value, $726. Actual cost, $726. On target. And finally, value of work, $798. Actual cost, $845. That is an unfavorable cost. So again, that is the variance. You have schedule variance, and I'm good. I love charts because it's easier for me to remember how to calculate the schedule cost versus the cost variance. So schedule variance, cost variance, and you see how you compare. So it's best to set it up this way, where your budgeted cost of your work schedule, budgeted cost of work performed, and then do your comparisons that way. All right, well, I'm not going to be going through all of page exercise 2.2.6 on page 2.2.75, but I do want to point out on page 76, in order to do an economic analysis exercise, worksheet, which is on page 77. So your sheet is probably blanked with alternative 1, A, B, and C. You have columns 1 through 9, and you have initial cost, annual operating costs, and so forth. What I want to point out to you, let's go to alternative A. Now, they're not going to set up the problems in a nice chart like this for you. They're going to give you a scenario such as listed on the bottom of page 75. They'll give you alternative A, alternative B, C, D, E, F, G, whichever one. But they'll give you the information written out in a scenario base, such as listed on the bottom of page 75, and then you will take that data and you will plot it out. So again, that's a little chart that you can recreate to do it on your own. So the initial cost of alternative A on page 77 is $12,000. The annual operating cost, and that's listed in the problem, is $15,037. Column 4 says a series of payment discount after the 6th year. So what's your discounted factor? The discount factors, you will have to go to the chart on page 76, and most likely this information will be given because you won't be able to recalculate it. So let's look at, you have two charts. In the middle, you have one for 5% table for a single payment, and on the bottom of page 76, you have for a series of payment. So your single payment or non-recurring, meaning every year I have a different dollar amount, or there's a different dollar amount in one of those years. The bottom of page 76, the series of payment mean my operating cost is exactly the same number every year. That's how you know which chart to use. So when I go back to page 77, alternative A, for column 4, where it says, what's my discount factor of that $15,000? Because the first year I paid $12,000. $12,000 is worth $12,000. However, annual operating cost is year 1, 2, 3, 4, and so forth is $15,037, but that will not be worth $15,037. So the discounted amount is, if all the payments are the same, I use the bottom chart of page 76. So I go all the way down. It's a 6-year project, and you will only know that by reading the scenario case study on page 75 Oh, I think they reset it again at the top of page 77. It's a 6-year project. So on page 76, on the 5% table, I will use the table at the bottom of page 76. I will go down time period number 6. To the right of it, that factor is 5.07569. So for all my series of payments, and the bottom of page 77, it tells you how to calculate columns 4, 6, 7, 8, 9. It tells you how to do those calculations. So you put 5.07569 in each one of those, A, B, and C, same thing. You have your salvage value, that's the cost of the item when you get rid of it in the 6th year, or the end of the 6th year, or you could say the 7th year. That $12,000 item is only going to be worth $1,000, or is it? Because you have to discount that $1,000 in that 6th year. So column 6 is, because the salvage value is one value, it's a single payment, I go to page 76 for 5% table for a single payment. I go down time period number 6, to the right of it, I see 0.74622. That is the number that goes in column 6 for alternative A, B, and C. And when you're comparing alternatives or courses of action, you have to compare them on the same level. If it's a 6-year project, you got to compare all 3 for the 6-year project. Present value of operating costs, column 7, it says multiply the dollar amount in column 3 by the discount factor in column 4. So if I multiply the 15 times 037 times 5.07569, you should get 76,323.15. Present value of the salvage. What's the present value of that $1,000 that I expect to get for the item? Today's dollar amount, that present value in 6 years is that 1,000, column 5, times column 6, 0.74622. The present value of the salvage is $746.22. I'm still on A, alternative A. And the net present value, so the total cost of, if I buy alternative A, the total cost of that investment based on what I know today, if I add up the columns like it says in 9, net present value is a sum of columns 2 and 7 and subtract, because you got to subtract the salvage value. Because again, salvage value, everything else is money going out, but salvage value is money coming in because I get rid of the item and somebody pays me. So you got to make sure that you minus the salvage value. So it's, what do we have here? All right. So the value should total $87,576.93. So that's everything added up minus 746.22 should get 87,576.93. And you do the same thing for all the other ones. And this will conclude review of CDFM Module 2.2, Cost and Economic Analysis.